In this video, we're going to look at finding all the zeros of a polynomial function. There are a couple different ways to do this. We're going to make use of some of the graphing technology we have. So either your graphing calculator or a website such as Desmos or another online graphing utility. The first thing to do, though, is to look at the possible zeros. So to find the possible zeros, we are going to do plus or minus P over Q. Okay, so that's kind of shorthand. We got to know what that means. So P is the factors of the constant. And then Q is all the factors of the leading coefficient. Okay, let's make sure we know what constant and leading coefficient mean. So what it means is we're going to find all the factors of the number without a variable and then divide all those possibilities by the factors of the number in front of the variable with the largest exponent. Now, if it's in standard form, which most of the polynomials you see will be, you can just think of the last number and the first number. But be careful that the exponents go in order if you're going to do that. Okay, so to find the possible zeros, I should say rational zeros. We're going to list out the factors of 20, which are 1, 2, 4, 5, 10, and 20. So let's pause and talk about where those numbers come from. So those are numbers that multiply to 20. 4 times 5 is 20. 2 times 10 is 20. 1 times 20 is 20. Those are all factors. The plus or minus is there because we could have like a combination of both of them are positive, both of them are negative. So negative 4 is also a factor of 20. On the bottom, we just have 1. So it's not a super interesting example at the bottom because the factors of 1 are just 1. So 1 and negative 1. And this is a somewhat acceptable way to write this out shorthand, but what it really means would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and then I'm running out of room a little bit. We'll go to the next line. Plus or minus 10 and plus or minus 20. So all of these are all your possible zeros or possible rational roots or rational zeros. Okay, and that's good to know. Now, if this were back in the day, we would have to just plug these in. There's no other way to do this really. Just plug them in and see what you get until you get 0. You could use synthetic division to do this also. But because we have the technology to graph things, now we can just look at our graph and see if we can identify the rational zero from there. So let's go to a graph. Okay, so this is the graph of the function for number 1. So we type this in over here, x cubed minus 8x squared plus 11x plus 20, and we're looking for the zeros. Okay, so we have all the possibilities. The smallest possibility is 20, negative 20, and the largest possibility is 20. So, but we could zoom out and you probably could tell that it's not going to hit, but there's not a 0 at 20 or negative 20, and the 0 is the x-intercept. But I can see, if I zoom in, that there is a 0 at negative 1. And so we know that x is equal to negative 1 is a 0. So then we're going to graph to find a 0. So we found x is equal to negative 1. And you can even see the rest of them here too. So 4 and 5. We're going to use synthetic division to see those other two, though. Not because you have to do it for this problem, but when we work with imaginary numbers, you will have to use synthetic division, and it gets a little bit more complicated. So let's try to do it with real numbers, and then down the road, it'll be a little simpler, hopefully. So we know x is equal to -1 is a 0. We can also say that also means that x plus 1 is a factor. And that's a good relationship just to really get down. And actually, we got to go back to the, let's go back to the paper here. Okay, so we're back here. So we know x equals -1 is a 0 from the graph. And then x plus 1 is a factor because I could just add 1 to both sides. And so now what we can do is do synthetic division. Let's divide by x plus 1. So the 0 goes in the box. 1 minus 8, 11, and 20. And you bring down the 1. And then add those together to get -9. Multiply to get 9. Add them together to get 20. And multiply to get -20, and you get 0. Which is what you want because you think it is a 0. So that confirms that -1 is a 0 because there's no remainder. And so now this means that this is x squared. Let's move this up a little bit. X squared minus 9x plus 20. Okay, so what does this mean? This is where it gets tough. So we started, let's put what we started with over here. F of x is equal to x cubed minus 8x squared plus 11x plus 20. So we started with this. Well, then we divided out an x plus 1. So divide x plus 1. Oops, minus 9x plus 20. And then now, if you see, this is something we could find zeros to. You could repeat the process, or you could factor. I need two numbers that multiply to 20 and add to -9. And those numbers are -5 and -4. So we have x plus 1, x minus 5, and then x minus 4. And then the last thing we're going to see is that all of these can be set equal to 0 to find the zeros. So we already did that one. X minus 5 is equal to 0. And then x minus 4 is equal to 0. So x equals -1. X equals 5. And x equals 4. Okay, so this is a long question. Right? There's a lot going on here, but we also answered a lot of questions. So let's look at, and an important thing is keeping track of like what we're actually answering. So let's look at that real quick. So go back to the top. Right here, we answered the possible rational zeros. Okay, so if they ask for the possible rational zeros, that's what we're looking for. Just the possibilities. Over here, right here is where we factored completely. So if they ask to factor completely, then there it is. Then this is what they mean. All in parentheses, all have a power of x to the first power. And right here, these are all of the real zeros. And you don't have to do everything on every question, just answer the question. But this is what it's looking for. And then make sure you kind of know what we did. You stated the possible rational zeros, and that's from the factors. Then you look at the graph to find a zero. So remember this step, graph to find a zero. And you really only need one, but if you want to use all of them, you could just jump down to this step and be done, right? You could list them all out right here. Then you can use synthetic division and factoring to find the rest. Okay, let's look at another example. And I want you to try this one on your own. Pause the video and list out the possible zeros. Let's do it this way. So you want the factors of the top, which are 1, 2, and 4. 1 times 4, 2 times 2. And the factors on bottom, which is 1 times 6, 2 times 3. And then if you wanted to list all these out, the way you would do it is you do 1 over 1, which is just 1. 1 over 2, which is 1/2. 1 over 3, which is 1/3, and 1 over 6. And then just keep going. 2 over 1, which is 2. 2 over 2, which is 1. You already have that. 2 over 3 is 2/3. 2 over 6 is 1/3, which we already have. 4 over 1 is 1. 4 over 2 is 2. We already have that. 4 over 3 is 4/3. And then 4 over 6 is 2/3, which we already have. Okay, so those are all the possible zeros. So if you ask for the possible ones, list all those out. It's kind of a, kind of a lot to list them out, but hopefully you don't have too many factors here. Then if you want to find, we're going to graph to find 1 0. Okay, so let's go to the graph. Okay, so here is our graph, and you can see we have the problem typed in from the original function. Use y instead of f of x. And you can see the zeros look to be, so that's negative 0.667. Okay, so that's a fraction, 2/3 fraction. We have 0.5, which is 1/2, and then 2. Okay, so you could write the factors from here, but we're going to use synthetic division. And once again, we're doing synthetic division now because if these roots were imaginary, that's the only option. So practice it now while you can. But we know that x is equal to 2. So let's pick the non-fraction answer because, if you can avoid fractions, go for it. That means a factor is x minus 2. Okay, and just those things should go like hand in hand in your mind. But this is tough stuff, so it's going to take a little while. And then we do synthetic division, bring the 6 down, multiply 1, 2, -2, multiply and add, -4. And you should get 0 because we know it's a 0 from the graph. And I just realized I'm still on the graph. So let's go back to the paper here. Okay, so I just realized I was sharing the wrong thing. We'll see if I edit that out or just keep it in. Okay, so here's the synthetic synthetic division we did. From the graph, x is equal to 2 is a 0. Then x minus 2 is a factor. So we divided, we brought it down, multiply, add, multiply, add, multiply, add, and you get 0. So make sure you pause that and make sure you have that worked out. The 0 is important at the end because that tells you probably did something right, because you thought it was a 0, so there should not be a remainder. Okay, so what does this mean? Okay, so let's write this. This is 6x squared plus x and then minus 2. So what this means is I can rewrite the whole thing as x minus 2 as a factor, and then 6x squared plus x minus 2. So that's bringing in what we found up here from the graph, and then these. Now this is some factoring you need to do. So we'll review the AC method here. Two numbers that multiply to -12, and then add to 1, which are 4 and -3. There's a couple different ways to go from here. You could divide by 6 and reduce those. We're going to do it with factoring by grouping. So we'll ignore the x minus 2. So 6x squared, we use these numbers to rewrite them as 4x and then minus 3x minus 2. Once again, this x minus 2 just stays there. These have a 2x in common. These have a -1 in common. And then these look the same. And we looked at these first two and these last two. And then notice that these are the same. And so that's x minus 2 stays. 3x plus 2 is one of our parentheses, and then 2x minus 1 is the other one. And so this is now your function. This is factored. And if we want the zeros, then we can set each of these equal to 0 and solve. So just add 2. We already know that one. Let's do it in one step. -2 and divide by 3. And then add 1 and divide by 2. And these values are your zeros. So once again, there are possible zeros here, possible rational zeros. We have the graph and then synthetic division to find the factors, and then the zeros here. Okay, so good luck with this. I would probably rewatch some of this video. Definitely pause it, give yourself time to think, and reach out if you have questions.